from. Please, if my voice is audible and the screen is visible, please let me know before we start the first session. Very well. Um, in these two sessions, today and tomorrow, you will get an understanding of what a data management and what data science is, and how these two things can go hand in hand into improving your overall workflow and boost your career in the current digital industry that we are seeing the transformation happening as we speak. So the idea is not about learning new things. The idea is we need to implement new tools to boost our productivity. That's the important thing that we care about. We don't care about the tools, we care about the idea, and we care about how much productivity that we can increase. In this session, you should see lots of examples, lots of things that can resonate with you, especially bad data management practices. And basically, I will show you how to eliminate these in few simple steps. So before we start even our presentation or talking about technical stuff, let me introduce you to something called data chaos. What is a data chaos? So let's take an example. Let's say we have two engineers, the first one called Jack and the other one called Joe. These two engineers, they work in the same domain. Well, sometimes they even might work on the same team. So what happens between these two engineers? They basically share insights, they share data, they share reports. So Jack, which is the person on the left-hand side, is much more experienced than Joe. So basically, Jack usually distributes and gives task to Joe, and Joe modifies the files and send it over to Jack. So Jack will review it. Maybe he will add his own inputs and send it over to Joe. So basically, there is a back and forth file sharing and file sending between these two persons. Does this sound familiar to you? Well, let me show you what's the problem with this. So let's say these two persons have exchanged and shared, let's say, 5 or 6 emails. Now, the first email that was sent between Jack and Joe, let's call the file generated from this email as file version 1. And this file can be anything. It can be related to production management. It can be related to reservoir management. It can be related to petrophysics. It can be related to well integrities. It can relate to anything that you can think of. The concept that we're presenting is universal concept that actually applies on everything. So the first email generated the first version of the data. The second email generated another version, and so on and so forth. And finally, whenever both of these parties agree on a particular format for the data, what will happen? That particular final version will be distributed to other engineers. And now suddenly, other engineers are generating their own versions. I hope you see what I'm getting from this. The problem is, how can we manage all of these versions? Which version is the most correct version? Which one is the most updated version? Well, nobody knows. How many versions do exist? That's also something we cannot answer. Nobody knows how many versions do exist. I'm 100% sure that you've already seen something similar in your workspace. This is basically how badly we manage our data. Now, let me show you how we can eliminate this. So the data chaos has generated few things for us. And these few legacy things we have been inheriting from different decades in oil and gas industry. So we have wasted time moving data back and forth. We have introduced errors into our workflow with possibility of using an outdated version of our data, which is something that you might resonate with. Plus, there is usually delays with these emailing and back and forth and basically approving on these data. So the process, you can see it's not very efficient. Why it's not efficient? Well, because not we are not leveraging the rules and the concept of data management and data science altogether. That's why we're having all of these problems. So how can we solve this problem? We can solve this problem by using a standardized data source, or we know these as databases. More comes on the databases on the later slides. So in order to solve these problems, we need to do 3 steps. Number one, we need to standardize data. So what does this mean? Well, no engineer has his own data. The data ownership is belonging to the company. If you want data, well, you will basically get the data from the source. So this leads us to the second point, which is the single source of truth. So what does this mean? So let's say we have a technical team working on a particular project. So let's say they are working on a production monitoring or production allocation project. This project will go up decades upon decades. Each engineer will have his own version of files, maybe with different units, maybe with different calculation approaches. Who knows? But can you tell me, or who can decide which one of these file versions is the most correct one? Actually, no one knows. So what is the solution? The solution is if there is a calculation or if there is a standardized workflow, well, that workflow should also be incorporated in that particular standardized data file or standardized database. So what will happen is all of these users are going to connect to that particular source and all of them will get the same answers. Plus, this leaves us to this third option, which is the real-time collaboration. It's not possible to have the real-time collaboration unless you know how to work with data technology and how to leverage data science to your favor. In this training, we all present all of these 3 steps, including the real-time collaboration, how to create data, how to consume data, and basically how to convert data into an actual insights that's basically standardized and everyone can get the same answer each and every time they are using the data. So that's basically the bottom line of why we're using such a technology. So where does the data science comes into play? Data science allows for a better decision making. So how is this possible? Well, if your data is up to date and you know for sure that your data is consistent, there is no problem with the data, and basically you can get high quality results because based on the rule, garbage in, garbage out, well, if your data is not in high quality, the answers and the decisions are not going to be very good. Plus, there is an advantage of data science, which is the automation. So what does the automation mean? Automation is basically the capability of human beings to make machines do things for us automatically. So this is basically what an automation means. However, the automation has many, many levels. Depending on the level of complexity, well, you can start basically with very, very simple step, which is also considered as an automation. For example, there are some companies, what they do is whenever they get new data, they write a particular Python script to scrap data from these emails and then basically tabulate these data and basically send these to the corresponding persons that are subscribing to these data. So that's one of the automation things that you can do. Plus, I have seen some companies, what they do is whenever they have new data arriving from the field, especially whenever we are applying digital oil fields, what they do is they automate email sending to people. Basically, they will extract data at 7 a.m. in the morning from these databases, which is basically what we're covering in this training. Once they extract the data, they will attach the data into emails, and all the people subscribing to that particular service, they all get the data before they are even heading to their desk office before even the work starts. So that's one of the benefits that we get from combining data technology with uh, with data science. Plus, we also get dashboards or live dashboards. Most people, what they do is they visualize data with Excel. And basically, there is nothing wrong with that. That's just okay. But the problem with Excel is usually it's very rigid. It's not so flexible. Plus, uh, user can do anything with Excel. User can easily destroy or take some information out of the plot or out of the context. But utilizing data science tools, we can create fast, efficient, and live dashboards. User can use it to what extent they want. They can be power users or they can just be a simple user for these. Plus, these live dashboards does not have to be always connected to databases. We can connect these to standardized Excel sheets or multiple Excel sheets at the same time, which is something that you cannot do in the regular Excel sheets. I have an example in the upcoming slides, and I will ask you what you would do in that case. So we will see that in the few slides. Plus, one of the most important things that we usually do in the data science is usually this is going to be the final step of the data science, which is the ability to generate forecast or the ability to tell something how this is going to be performing or going to be predicted in the future, which is basically machine learning. Machine learning is nothing but few equations and few methodologies that learns and applies pattern on your data. Once you find these patterns, you can predict anything you want. And how to do machine learning? Well, the key step to machine learning, or more properly put, 80% of the work we do for machine learning and the forecasting involves organizing and tabulating and basically cleaning the data. If you have all of these already in place, well, applying machine learning, it's going to be very, very easy and brief. So why data is so important in oil and gas industry? Nowadays, oil and gas industry is generating massive data. Since we have implemented digital oil fields and digitization is happening in everywhere, we are getting digital well logs, we are getting digital production, we are getting digital drilling reports. We already have SCADA and DCS system that can basically transmit data to remote offices, or even we can get those data on the well pads. Basically, the bottom line is we are generating too much data. Plus, we have too few personnel to see and review these data. So that's why data science and data management should come into place starting. We started doing that in the previous years. So it's extremely important. We have few employees and we have much, much more data getting in as compared to the 80s and the 70s. Plus, usually there is something called real-time decision making. So what's a real-time decision making? Depending on the data that you're getting from the field. Now, what happens if the data is showing you a particular signal? Maybe the data is showing you a hidden pattern. Maybe one of your wells is going to shut off, or one of the ESPs you have is causing a problem. Well, you need to understand how these can come into play. These usually are treated by training machine learning models or artificial intelligence models. However, without the proper data and without the clean data, this is not possible at all. So in data management, basically what we do, we apply a particular set of practices to organize and basically utilize the data in the best way. Now, let me ask you a question. Let's say that you have data coming from few assets, and these assets can be wells, reservoirs, reservoir simulation cases, drilling reports, and let's say production reports coming from different facilities. Let's call these asset one, asset two, asset three, and asset four. Now, Usually, what we do in engineering practices, we have few things to do. First of all, what we do is in engineering practice, basically we measure and monitor these things. Basically, we take a look at the graphs and we see how these things are performing, right? This is one of the basic tasks of what we do. Now, this task is very trivial and it's easy to do, especially if you know your way around in Excel. Now, the most important thing is since we have four different assets, these four different assets are combining, or let's say they are generating four different files or four different data. Now, how can you combine these data? Well, are you going to copy and paste these manually? Let's say that these assets are generating data on daily basis. So are you going to do this manually every day? That's one question. Just think about that. Now, it's not always about copying and pasting. Now, what happens if you want to compare the asset one to asset three? Or maybe you want to compare everything together. Maybe you want to see how these things stack next to each other. What's your answer to this? Are you going to copy and paste? Well, that's usually going to be the answer for this problem. Because persons who rely on Excel sheet for everything, basically this is going to be the answer. But knowing the right tools and knowing the right ways to work with the data, using few lines of code only, you can automate a script that combine and compare and plot this data for you each and every time you run the file. Or even better yet, you can convert this into a Microsoft Windows task where this thing can run each particular number of hours. Let's say it can run 8 a.m. in the morning or 12 p.m. or 5 p.m. You can automate that. Plus, how can you generate statistics from these? Are you going to generate statistics manually? Well, we can always automate that using the right data science tools. There are much more things uh, than just statistics and combining and comparing these. However, for simplicity, we are just presenting these. Just think about these questions. Please, so far, if anyone has any question, please feel free to ask in the chat box. So in data science is just a big umbrella of different concepts and different methodologies. However, all of these methodologies and tools, they all lead to a single thing, which is the ability to automate things, make things easier, make things faster, and more importantly, create solutions and workflows that are repeatable each and every time because you're not going to waste your life by copying and pasting between different files and different Excel sheets. So your time as an engineer is much more than that. So what we do in data science? In data science, and basically one of the main tools of data science is Python. We do data collection. We start scraping data. We collect data from different sources. And this is the beauty of using Python. You can create a single project. That project can feed on hundreds upon hundreds of files. In our previous trainings, we usually teach or we taught our participants how to read 20, 30, or even sometimes we went extreme. We read more than 100 LAS files or 100 well logs files with a single click. There is no software that allows you to do that. Plus, scrapping more information about these, it's going to be much more hard to do in commercial softwares. But since we are using Python, it's easy, it's flexible. It allows us to do different things. Plus, the in the April of 2024, we started our machine learning training. So that was more than 35 hours of learning. In this training, in the middle of the training, one of the projects that we did involved reading more than 20 LAS files we extracted gamma ray, SP, and few more mnemonics, and basically combined everything together. Like also, we kept the source or well, the well name as a separate column. Once we combined these, we generated a particular file that basically combined these 10 wells. And we generated something close to 50,000 rock properties or points or readings from the last, depending on the property of the rock. Once we did that, we fed that into machine learning, and we started to do forecasting based on those 10 wells for places that are undrilled yet. So this is one of the things that you can do in data science. Of course, this is not the only thing. This is one of the examples that our people trained at. Plus, one of the things that people usually do in data science is exploring the data. Exploring the data can be done in many, many ways. We will see this today a lot. I will show you how to explore the data in SQL, and then I will show you how to create a further exploration in Python. Plus, you will build the model, or you will build your insight, or you will build your final calculation, and then you will deploy it for other people to use like yourself, or maybe other teams to consume. This deployment can be as reports, or it can be as interactive applications that we're going to cover in this training. So the important things that we need to understand from the things that we have presented yet: data science, SQL, data technology, Python. Well, these are not just fancy names anymore. These are required nowadays to make everything faster, calculations easier, and so on and so forth. Now, you might ask yourself, well, maybe I want to create a single well plot. Well, in that case, I would discourage using Python and data science, because plotting a single well is something Excel can do very, very well and very, very fast. But what happens if you want to compare 100 wells at the same time? Well, you only have two options. Either you use data science and Python, or you can use a commercial software that's going to cost you more than 25,000 USD. Plus, you should embrace machine learning as well, because machine learning is going to be the cherry on the top of the data science, because machine learning will give you the capability to predict things. Now, enough with the theory. Let me show you a few things. First of all, I will show you what a data technology is, and then we will move forward with different things. So let me open my drawing application. So let's say that we have different assets. So these assets can be anything. So let's say we have different wells, basically generating different types of data at different frequencies. So this is, let's say, well one. Let me copy and paste that. Let's say this is well two. And we can have more wells, by the way. And let's keep this interesting. And let's say we have other things like pumps. And we have different facilities like central production facilities. Okay. Now, how do we want to approach this? Well, usually each measurement or each reading usually, or sometimes even a job, can generate a file of its own. So for well one, you might get one file. For well two, you also get one file. This is at least. For this pump, you will get at least a single file per day, basically showing you the operation that's happening on this pump and the operating hours. So this is per day. So a CPF, you will get sometimes minutely or second readings. Now, you have different data frequencies or different data sampling happening. So what you're going to do, are you going to open a separate folder for each well and each asset? So each well will have its own file, or you're going to assign an engineer that copy and paste everything to a single file? Well, that's not a very good practice. What we can do is we can create a simple code script that basically reads off everything as it comes from the field. And then this single script will transform everything to a centralized database. So I will tell you what a database is. A database is nothing but a container that basically contains and holds data. Database is composed of two or few main things. So the first main thing, we have something called a server. A server is nothing but a process that's running on the background. That's it. Inside the server, we have something called database. Now, this database is actually the container that we are going to use to save the data. But you cannot save data directly into the database. You have to organize and categorize that data. And these data are organized and categorized with something that you're already familiar with, which is a table. So each operation type will have a table of its own. For example, you will have a table for injection, you will have a table for production, you will have a table for gas burning, you have a table for different petrophysics, you will have a table for diesel consumption. So you will create those tables, or sometimes these tables are already created. So once you have these tables in place, so let's say you will have X number of tables. Now, how can you retrieve data from these? Well, because we are all about standardizing everything. Well, we already have something that is invented in the 70s. I think it's either 74 or 76, 1976. Some scientists invented a language that basically can talk to data. So the language is called SQL. SQL is short for structured query language. SQL, it's not a type of database. SQL is the language that we usually use to talk to data. Now, you might ask yourself, why do I need a language to talk to the data? Well, because it's more precise, easier to read, easier to execute, and much, much more faster than you think. So let's say we have an Excel sheet, and that Excel sheet contains 100,000 lines of worth of data. Now, do you think that Excel will process that very, very fast? The answer is going to be no. Excel will start to slow down way, way before you hit the limit. By the way, the limit for Excel sheet, I think it's something close to 1 million lines of worth of data. But even after 50,000 lines or 100,000 lines, Excel will be very, very slow. Whenever you do a particular process or a particular calculation in Excel, well, the Excel will be very, very slow. Now, people already know this. So that's why they rely heavily on databases. So let's say that we have a particular user, and that particular user, let's say that it's Joe. Joe wants to get production data. Plus, he wants to get some XY data, which is basically the location of the assets. And he also wants to get the data for the separation and the separation process that's happening in the CPFs. So what he will do, he will write an SQL query. Once he writes this SQL query, now he gets the data. But how he gets the data, how he consumes the data, and what will happen to the data afterwards? Well, Joe has 100% control over it. If Joe decides to combine the production of the wells, well, he can do that. If Joe decides to assign the production of the wells to the separators, well, he can also do that. Now, how this is possible? Because we have separate tables. You can imagine those separate tables as separate files of their own. Well, this is the magic of SQL. SQL has a very strong engine and it's a very powerful when dealing with discrete, non-continuous data. This is basically the sole purpose of using SQL. It's so powerful, you will be amazed on what has been left out, and you did not learn that fast and early in your career. Now, let me show you some practical example on SQL. So in order to work with SQL, what you need something called an SQL server. And SQL server is something that usually we found free online. However, you need to populate it with data. In our training, we all provide you with the databases. The database is there. You will just practice on it. Plus, we will teach you how to create those databases towards the end of the training. So in this installation instance, we have three databases. You can think of that each database actually represents a particular field. So for example, let's say that we want to work with this database, which is called OilDB2. Let's say that this is a particular field. What we usually do is we will try to create an SQL query. An SQL query is just a very, very, very simple programming language that we usually use in order to talk to data. The simplest and the most powerful command that we usually use is called a select command. A select command is used in order to retrieve part or all of the data. So let me show you. If we open up this database, we will see that there is a folder called tables within it. If we expand these tables, we will have all the tables listed for us. You can think of each table is equivalent to Excel sheet. So let's say that we're interested in this table, which is called XY. So we will do a select command. We will say that select all. The stars means all. Still, select all from the name of the table, which is going to be X and Y. Now, let me show you. Once you press on execute, you will retrieve all the data. So let me show you. Once we click on execute, there we go. Now we get all of the data. On the right-hand side on the bottom is actually the execution time. You can see that it took it 0 seconds to read this data. Now, just imagine what happens if you open an Excel sheet with the same data size. Well, at least it's going to take a few seconds. As the data grows, the slower the application or the slower the Excel will get. So that's why we usually use these types of applications to facilitate reading and writing data. Now, this is reading X and Y. Now, we can do one more thing. We can read another table. So we will say select all from SC. SC is just another table that contains different namings and categories that describes these assets. So let's run this. Now we have two separate tables already in place. If you want to throw in the production data into these as well, you're also going to add a select statement. So we will say select all from PRD, which is production data. There we go. Now you're combining three tables at the same time. So whenever I click run, this is equivalent to opening 3 Excel files. So you can see how fast this is. It's blazing fast. It's not just about reading data. You can also create calculations inside this query or this script. Before we move ahead, one of the things that's possible and it's easy to do is to combine any number of tables together, which is extremely, extremely hard to do in Excel. Why is this? Well, what is the basis of combining the table of XY with the table of production? Well, XY table is just a static table, meaning that it does not change with time. However, the production table grows with time. It grows vertically because the more production data you will get, the more rows are going to be added. So the production data contains something close to 20,000 lines of rows. However, the X and Y table contains 160 lines of rows. If you try to do this in Excel, well, it's very, very hard and it will give you a headache. I'm not saying it's impossible, but it's extremely hard to do. In SQL and database management, it's so easy to do, it's going to take you only a few seconds. I have already prepared such a thing and I have saved it inside another table. I already called the table full header. So this is another table which is called full header. If you run this table, you will see that SQL has managed to combine everything together for you. And it's generated a huge table for you, which is not possible in Excel. So now, how can we proceed further? Today, I will show you the easy way to proceed forward. Now, we want to do some analytics on top of these data. That's very easy to do. You can do lots of things. For example, you can count how many wells you have. You can find the deepest well. You can sort the deepest well. You can sort the wells by the date of completion. For example, let me show you the latest drilled wells or latest well that was put on production, which is this column on prod date. So we will do something like this. We will say that order order by is just a sorting action. Order by on production date, which is the name of the column. And we will say that please order this descendingly. The greater values is going to be on the top. So let's click on run. There we go. Everything now is ordered backwards for you. Now the newest well was added in 2008. This is just one of the few things that we can do. Let me show you how we can take this into Python and apply some more data science to this. So what we will do is, this is the results of the query. You don't have to export this to anything, by the way. Now, this is the easy part where you can integrate Python with SQL. We will right click, we will select everything, and then we will select this option, copy with headers. Once you do that, now it's copied to clipboard. Now, let me show you what we will do in Python, which is going to be very, very amazing, and it's going to be very easy. So I already have my Python file ready to run. This is a recent application that was added to Python. It's called Marimo. It's very easy to use and it's very intuitive. In Python, in order to read any type of files or any type of data, we have a standard library, which is basically used by upon hundreds millions of people. And I'm not exaggerating, by the way. The library is called Pandas. So once we read Pandas, there is another library we can import, which is called Plotly. Plotly is a library that's very easy to use. It's somewhat fast and it's interactive, which is very important. So once we read these two files, what we can do is now we can start to get the data that we copied into Python. So let me show you. I will create a variable. I will call it data. So I will be using pandas to read from clipboard. So I am not going to export SQL into file. I am not going to do anything fancy. I will just take whatever was in the clipboard and Python will explain this and basically it will break it down into different columns and rows and you will see how easy it is. And basically this is it. You don't need to do anything else. We will just type data to print it out and click on run. There we go. Now this is the data that was copied from SQL. And basically you get this nice exploratory data analysis view. For example, you can do anything. For example, you can sort this further ascendingly or descendingly. You can just select anything you want. You can convert this to capital to small. You can do basically lots of things that are in the ways of interacting with this data. Now, this is not the only thing we are going to do. No, I'm going to show you how we can leverage this and create very simple yet very effective plots with this. So, for example, this data contains, for example, the x-coordinate and the y-coordinate. So basically using these two coordinates, I can create very easily a contour map. So let me show you. So I will create a simple contour map using Plotly. So we're going to use a contour map and we're going to provide our data. And on the x-axis, I'm going to use the x-coordinate. By the way, this contour mapping thing, it's so flexible. You can use it for anything. You can use it for porosity, permeability, petrophysical properties, pressure data, production data, anything that you can think of. So for the y-axis, I am going to set this to y-coordinate. And once we have these things, let me show you how this is going to look. There we go. Now these are the contour data. Of course, we can add more data to this. For example, we can add also the depth data, and I'm going to use the total depth for these wells. And one final thing that we're going to do is we can also fill these up. So what do I mean this? You can fill the contours by adding different colors to these. So let me show you a ready-to-use solution I have created for you. So if you want to make sure your contour looks like this, which is a possibility, you only need to do this line, which is basically contours coloring fill. So let me show you. So we will do something like update. So we are going to update the plot, and we will say that fill the contour lines for us, and then click on run. There we go. Now this is how your contour looks like. Now this contour is basically doing a count. If you want to do an average, that's also possible. This is how easily we can convert the SQL into simple contours. Let me show you one more thing. We can also utilize the total depth in order to plot all the wells and show the depth of all of these wells. So let me show you. We will create another Python code, and we will say that plotly express dot bar. So we're going to create a bar chart based on the data. X axis is going to be the wells, and the y axis are going to be the total depth of these wells. So once we do that, we are going to get a plot that looks like this. Now, these are the names of the wells, and these are the depth corresponding to each well. Well, this is not very explanatory because these wells can represent anything. So this data set contains lots of information. So one of the information it contains is actually the type of the well. So let me show you how we can color this type based on the type of the well. You will only add two words, which is color equals to the status of the well or the type of the well, just like this. Once you do that, there we go. Now the gas wells and the abandoned wells, oil wells, injection wells, each well will have its own types of coloring. Now, maybe you don't want to do something like this. Maybe you want to break down the chart by the type. So you will have separate field for gas, separate field for oil and whatnot. So let me show you. We will use something called facet column. Facet column is just basically a way to break down your plot into subplots, which is something not possible in Excel, by the way. So we will use the facet plot. We will use the type of the well or the status of the well to break down this plot further. There we go. Now these are the different wells are being stacked up next to each other. For example, the first one is the gas wells. The other one is the plug and abandoned well, and the other one is the oil well. You can see how the different wells can be compared and stacked next to each other. One more thing you can do is SQL is not just bounded to this application. In Python, we can also use SQL. So let me show you. Now, just please remember that we have a variable called data. That variable data is basically holding all the data coming from Excel from SQL using the clipboard. I will further use SQL inside Python to filter down this data. So let me show you. In Python, we have this nice option to write an inner SQL, which is going to be an SQL command executed inside Python. We will click on it, and now we can select from within tables. So if we type select all from data, so this is going to be use the data that basically it's a variable in Python. Of course, we can use more things. For example, maybe I'm interested in a particular region in my field. So let's say that x coordinate is greater than, for example, 4, 5, 6, 111, 110, sorry. Let's add a condition where. So let's run this. There we go. Now we are getting only 156 rows. You can, of course, change this parameter to anything you want. For example, the great thing about this is not just result. This is already being saved as a different table. So let me show you. You will get this nifty options where you can change this to anything you want. For example, let's call this data frame or data X, meaning that this is X coordinate is being filtered out. We will click on run. Now, we can go back or revert back to Python and then utilize whatever data is now generated from SQL. So let me show you. If we revert back to Python again and type data frame of X, which is the new table generated. Click on run. There we go. Now you're getting the exact same data that you got from SQL. This is all I have to present today. Tomorrow, please make sure to join so I can show you how we can connect Python into SQL in real time. And I will show you how to create simple yet very effective dashboards and create some basic calculations with that also. Thank you so much for joining in today.